fifth lecture.
There was a recorder left on the stand after the lecture last Thursday. I turned it in to security, and they have it if you haven't already found it. I give it to the lady that's on the phone out here, and she passes it on to her lost and found. So anyway, if you ever leave it, it'll probably be here. So today we'll do the lecture 4 on the integumentary system. It's kind of a relaxing, not too complex story. And we'll start out with some eye clicker questions. Actually, we're doing pretty well for this kind of class. We've only had one eye clicker session, and I've got all but 15 eye clicker responses synchronized with the students. So you should have your grade book on Blackboard should have a grade for you if yours is synchronized. So you should look, and I added another 15 I found that were added recently on Blackboard. So I think I'm down to 15 eye clickers that aren't synchronized. So check grade book today. If you're not receiving credit, please email me with your number on your back of your eye clicker, and I'll just manually add it. I'd like to get all of them in this week. It's really a hassle the longer we wait. So please send me your ID number today if you're not receiving credit. Okay, enough business. Let me go ahead and start with the eye clickers if you want to get them out. Go ahead and turn them on. These are about the histology lecture last time. So the first question, figure above has been derived from which class of tissue? So I said there are 4 different classes of tissue, so which class is this one in? Okay, I thought it was going to stop at 30, but for some reason I'll stop it at 45. I had it stopping at 30, so 5 seconds left. Okay, that'll be enough. These tissues all have very distinctive appearances, and this is definitely in the family of connective tissues. Let's see how if you agreed, everybody practically got it. 93% of you got it right. So whoops. So that's very good. So almost all of you recognize that as an epithelial tissue. I probably won't have many figures on the exam, but you will have to do this in lab. You will have slides in the lab, and that's usually the hardest part of the midterm practical, as the TAs will tell you this week. But I will have a few figures, and I'll tell you where they will come from before the exam. Okay, the second question. The figure above is indicative of which type? There are subtypes underneath the class. There are types of connective tissue. So all of these are connective tissues. Which of these types of connective tissue is this? Okay, I'll go to 45, I guess, again, so a couple more seconds. There's 39, 45 seconds. Okay. See how you responded. Almost everybody got that, maybe a little bit harder, but it's definitely areolar. Areolar is the type of connective tissue that surrounds blood vessels, and it's mostly a few fibers and some
cell types that are found in all connective tissue. So that's definitely areolar or loose connective tissue. Number 3, you would expect to find simple cuboidal epithelium lining. Another way to ask questions about this is, where is this tissue found? So where would you find simple cuboidal tissue? Okay, 5 seconds. And, okay, so a good way to look at questions like this is try and figure out what type of tissues you'd find at those other sites, in case that question was turned around. So you should also look at the other sites and see what you'd expect to find. But most of you said renal tubules, which is correct, 95% of you. The GI tract is a simple columnar tissue, almost 100%. Skin surface is stratified squamous. Oral cavity is also stratified squamous but not cornified. And respiratory tubules are pseudostratified ciliate columnar epithelium. So each of these has a distinctive type of tissue. Number 4. What type of muscle is this? This is a classic muscle tissue. What type is it? Okay. 5 seconds left. Okay, you can tell a couple things right off. If you look carefully, you can see striations. So it's either cardiac or skeletal muscle. By the way, dense regular connective tissue is very close to that. I did give it away because I said which kind of muscle, but dense regular connective tissue looks very similar, except it's not striated, nor does it have these large dense bars. So that gives up what it is, which is, I'll see how you guys did, cardiac muscle number, is that, yep, that's right. So letter E is the right answer. But it does look very, very similar to dense regular connective tissue. I think that would be the best second. It's not smooth because you can definitely see striations, and also smooth doesn't have these dark lines, which is question number 5. So let's look at question 5. The arrow indicates an intercalated disc, which is composed of a cluster of what kind of junctions? Three, 2 seconds, and I'll stop it. Okay, so remember I said the intercalated disc is the low resistance pathway by which these cells are excited or work together as a functional syncytium. We'll talk a lot more about muscle and its mechanics and the molecular mechanisms of contraction very soon, in a couple of weeks, but I just wanted you to know at this time that is a cluster of gap junctions, so 87% of you got that right, so majority of you followed that. Okay, so let's move on then. That's today's little eye clicker activity. So, most physiologists don't enjoy this subject because it's not at all very exciting conceptually, but the skin is an organ, and the organ by definition is a group of tissues working together for a larger function, and almost every tissue we've discussed, i.e. epithelial, muscle, nervous, and connective, has components within the skin. It is an organ, therefore, but it's also the largest organ, and it has very critical function that you could not survive without. So it shouldn't be discarded as something not very interesting to discuss. And a lot of our image of ourself relies on this tissue, this organ, and we spend a tremendous amount of money and time worrying about our skin and any defects and how we look to others and so forth. And indeed, dermatologists make a lot of money dealing with this organ system. Not only is it a sign of disorders, such as melanoma and many others that are very serious, it is also often indicative of diseases in other parts of our body, often show through effects on the skin their presence. For example, if we're have insufficient oxygenation or ischemic due to lack of blood flow or some form of anoxia or low oxygen, it'll show up by the blue appearance of our skin due to the lack of oxygenation and hemoglobin. So often the skin indicates not only by color but all kinds of other things, other diseases. So a lot of clinical relevance to this story. We usually divide the skin into three very broad layers, shown on the figure. The epidermis is the most superficial layer. Directly below that is a much thicker dermis. And then below that, sometimes not said to be part of the integumentary system, is a subcutaneous fat layer, which we call the hypodermis. It's mostly composed of adipose tissue. So we'll start out the most superficial and work down in these layers and talk about the histological appearance of each layer and some function of the tissues that are in them. So we'll start out with the epidermis, which is almost 90% composed of cells which we call keratinocytes because they produce their principal product is keratin, which we're going to talk about, protein, and so we call them keratinocytes. The deepest layer of these cells, that which is called the stratum basale, is very active mitotically, and unlike some of the other parts of the skin, this is probably the most mitotically active area. Another family of cells that are part of this epidermis are melanocytes, and you probably already realize that this skin has a cell component that produces a pigment called melanin, and melanin is a very black appearing pigment produced in these cells. They have appendages that come out, or processes that come out from the cell body that distribute this keratin into the neighboring cells. And so this is the dark pigment that gives that is more present when we tan and so forth. It gives our skin appearance. One of the values of melanin is it accepts protects us from UV radiation, and so it absorbs UV radiation so it doesn't get down to the lowest level of the epidermis. Another group of cells which aren't pictured in this figure are Langerhans cells, and I mentioned before that almost every different tissue has its own class of macrophages, and Langerhans cells in the skin have that role. They macrophage or phagocytize foreign cells and bacteria and so forth. And we'll talk about them more in other areas in the class. And something we'll talk about at length when we get to the early part of the sensory system is all the different sensory receptors in the skin. It's amazing how many different families, and each has a different receptivity. It's sensitive to one particular type of sensation, be it touch or temperature, or pressure, or whatever. And Merkel cells are in this family of sensory receptors. They're very close to the surface of the skin. We'll talk about them in more detail later as far as their function and where they're located. The epidermis has very little blood vessels. Most nutrients come from the lower levels, from the dermis, where there's plenty of blood flow. And now we'll talk about the layers within the epidermis itself, and they're represented here. The most deepest layer we call a stratum basale. It was called the stratum germinatum, I can't even say it, but anyway, we now call it basale because it's easier to say. Anyway, these cells are the active ones mitotically, and they're cuboidal, where most of the epithelium is squamous type cells, but these are very active cells, continually replacing the cells that move to the surface and are sloughed off. The next layer up, the stratum spinosum, the cells are spiny appearance, and that's largely due to the techniques which we use to preserve the cells and visualize them under a microscope. When you preserve this tissue, a lot of the cytoplasm is left, and what remains with the loss of the cytoplasm is protein filaments, in this case, that are hooked to adherens junctions, which you mentioned last time, on the edge of the cell. So it looks like these protein filaments are pushing out, like a pincushion, the edges of the cell, and that's what's thought to be the reason for the spiny appearance. Not so much mitotic activity, they're differentiating until the next level of cell. It becomes very active in producing the keratin. So the next level of cell is called the stratum granulosum, and it's named because under the microscope you can see all the little granules, and the granules contain the product of these keratinocytes, which we mentioned before, which is this protein called keratin. And keratohyalin is just another form of keratin. These granulosa cells produce this. It's stored in these granules, and then the granules exocytose or release this product out into the extracellular space, and it coats the cells around them. And the product is a water impermeable coating. It's almost like spraying oil on the surface of the tissue, and it makes the skin quite impermeant to water. It is fairly permeant to oil, it's like most of our tissues, but it's not very permeant to water, and it does help us not dehydrate as rapidly and so forth. The next layer down is not present all over the skin. It's called the stratum lucidum. Lucifer, you could think of. It's funny, Lucifer was named as the angel of light, but lucidum refers to light. And this is a clear area, and preservation, that doesn't look like there's any nuclei or granules or anything in these cells. They appear empty and very clear, and hence the name. This layer is very thin, if existent, on most tissues. It's represented right here. But this is what gives us the calluses in our hands, on the palms of our hands and the soles of our feet. So if you spend a lot of time with a hammer in your hand or running in bare feet or whatever, this layer gets quite thick, and so this is what we call calluses, if you will, in the lay vernacular. And finally, definitely majority of skin is made up of, depends on who you read, people say 25 to 30 layers. I think this book says 15 to 30 layers. Very flat, they're essentially dead cells. They have nothing no organelle activity anymore, and essentially there are cells that are coated, layers of cells that are coated and filled with this keratin material. And it takes about 15 to 30 days, and again, it depends on who you read, for cells to migrate from the stratum basale to the surface of our integument. And then they're sloughed. And sometimes they sit up there for a week or two, but eventually they're sloughed off. And so, of course, in your bed, as you've heard before, your sheets are covered with dead cells. That's why all the bugs enjoy it so much. So we're always continually shedding cells. So that means that we have to have a very active stratum basale. It keeps replacing the cells that we slough off on the surface. The next little section is on the color of your skin, and there's several different mechanisms that are responsible for us having some color in our skin. I've already peripherally referred to the melanin produced by those specialized melanocytes. The variation between the darkness of our skin apparently isn't due to the presence or absence of melanocytes. All of this, as much as they've been able to assess, have very close to the same concentration of melanocytes. The difference is how much pigment these cells produce with darker skin. People have far more melanin produced than lighter skinned people. And people with albinism that have no melanin lack the enzyme required for production of the pigment altogether. So evidently the difference is how much melanin is produced, not whether or not we have those cells buried. UV radiation causes these cells to produce even more melanin, and again, they release this into the cells in the area of the stratum basale, and that protects the very delicate mitotic activity from being denatured by UV radiation. So it has an important purpose. The melanocytes are responsible for several different situations or conditions of our skin. For example, freckles are due to aggregation of melanocytes in one area, so you end up with a larger than, a condensed layer, I guess you could say, or a large amount of melanin in one area. I mentioned already albinism, which is lack of melanin, is due to the absence of an enzyme needed for synthesis of melanin called tyrosinase. Vitiligo, which you might have heard of, is areas in which melanocytes are missing of the skin, and so you can have a very pale area versus the other areas around. And sometimes there's conditions where the melanocytes proliferate, almost like a cancer, but most cases this is benign and leads to a condition called hyperkeratosis. The second contributor of skin color, at least in the way I set up the outline, is keratin. Keratin you've probably heard of before. It's a pigment that's in plants, a yellowish pigment that gives carrots and peppers and other vegetables their color, and it's the exact same sequence of amino acids. It's a protein that is colored yellow, and it seems to accumulate in the stratum corneum, and it again, the amount of this keratin we have seems to be genetically organized or due to variances in genetics. So some people have more keratin in the skin. Skin appears yellower than others. And finally, hemoglobin has a significant effect on our skin color. As you know, when hemoglobin is oxygenated, it is a bright red in color, called oxyhemoglobin, and when it's deoxygenated, it's blue in color. So you can tell, but it's so the cyanosis, the blue color, occurs at very, very low oxygen. So by the time you appear blue, it's very critical. But anyway, you can have an indication of the oxygenation of a patient by his skin color. And we'll talk about that off and on in some different ways during the semester. Okay, so now we're going to leave the epidermis and go down to the deeper layer of the skin called the dermis. It's definitely thicker than the epidermis. This is a nice representation. And the majority of what's there is a lot of collagen and elastic fibers. And one of the reasons why we start having wrinkles and folds in our skin as we age is, for many reasons, elastic tissue gradually is digested as we age, and we lose elasticity. So our face starts sagging and so forth. We start wrinkling up. Then, as I said before, there's lots of blood vessels going through this area, and this provides the nutrition for the layers above, or the epidermis. And there's lots of glands in there that we're going to talk about off and on in the class: sweat glands and sebaceous glands, hair follicles, a whole families of sensory receptors, and nerves innervate these sensory receptors. Some of these structures we're going to talk about today, but we're going to say the sensory receptors and their function for the beginning of the nervous system, second half of this semester. Below the dermis, represented down here, is often just referred to sometimes as the subcutaneous layer. There's one loose connective tissue layer, and most of it is adipose tissue, as is well represented. And there's large blood vessels going through, arteries and veins going through. And it just essentially is connecting the integumentary system to the muscle layers that are usually immediately below it. The next logical thing is talk about a little bit about the function of skin, and most of these are pretty obvious. It is a barrier against microorganisms that surround us, and water and radiation, we've already mentioned, and its thickness will increase as we subject it to stress, as so much things do in our system. So as we use our hands to manipulate our environment and consistently use a hammer or something, we get calluses, or walk bare feet, we get calluses. Again, it regulates our system as far as fluid balance, and it's virtually waterproof, and if it wasn't for that, we'd have extreme dehydration, falling blood pressure, and horrible consequences. That's what happens with severe burns, which we'll talk about at the end of the lecture. We lose massive amounts of water and dehydrate. So it's very important as far as maintaining water in our system. Prevents either water coming in or going out across this barrier. One of the things that we put into usually the second semester when we talk about the cardiovascular system is how we use the skin to regulate our body temperature. It's the primary effector of temperature control. We do it a couple different ways. Through our sweat glands, we evaporate water from our system on the surface of our skin. And if you remember the story of heat diffusion, the temperature, the amount of calories that have to be absorbed to vaporize water, you will remember that this is a good way to lose energy, and that's what we do. We lose a lot of energy when we evaporate this water. People that have some spinal injuries lose the ability to sweat, and they have to have themselves or someone else spray their body with some sort of a mister if they're outside in a hot day. So it's a very important function that we seldom have to worry about. And the other part of the skin thermoregulation effector process is we can lose a lot of heat by radiant loss. If you've lived up in the northeast, and had a radiator in your home where steam comes up and heats this little device in your living room, and then that radiates out, same kind of process. In other words, we take the heat that's in the core of our body and take it out to the surface through the circulatory system. So we run a tremendous amount of blood flow through the surface of our body, through the integumentary system, and the only purpose is not nutrients as much as loss of heat. And so we continually lose this tremendous amount of energy that we have to lose to keep our temperature by radiant heat loss. And we can control how much of that in different temperatures by controlling integumentary perfusion, or we can vasoconstrict arterioles in our skin and shunt that blood to other places if we start getting cool. So when we're hot, we vasodilate, put more blood into the integument. When we're cold, we do the opposite. We keep the blood into the core of our body and maintain our temperature. We'll talk about how that's regulated and where the sensors are and so forth later on. The skin, like so many other organs, is responsible for a couple products. We already talked about melanin and keratin. Keratin is produced by the keratinocytes and melanin by the melanocytes. Also, we're going to talk in a whole lecture on calcium control about a very complex process of vitamin D metabolism. Well, one step in that process requires the UV radiation, which changes or hydroxylates the compound that eventually will be vitamin D. So we're going to talk about the activation of vitamin D by UV radiation. And down in South Florida, that's extremely active and useful, so it's always useful not to wear clothes. You get a lot more vitamin D. I don't know why so few people, when they get caught in compromised positions without clothes, say they needed more vitamin D. Very few people do. Seems like that would be a good excuse. These days we can use the absorptive qualities of skin therapeutically for many more reasons than we used to, but obviously there are things across our skin. UV light we've talked about in a very limited manner, respiratory gases, and although some organisms have significant gas transport across the skin, in us it's very small. But steroids, fat-soluble vitamins, toxins, and pesticides can cross our skin, especially if they're fat-soluble. And we use this capability or capacity for delivering drugs to great value these days in what we call transdermal systems. So these are patches that we leave in contact with our skin, and we can use it for administration of such agents as analgesics. There's fentanyl patches now. I know several people that use them that are very valuable in relieving pain, chronic pain. There are birth control patches, and you all know about nicotine patches. People that have nitroglycerin patches for overcoming chest pain due to heart attacks and so forth. Definitely we have all types of these transdermal mechanisms used, and there will probably be more in the future. As I said before, and we'll discuss this in chapter 15, we have the capacity within the skin to monitor our temperature, what we call the ambient temperature, the pressure that surrounds us, very fine touch, even vibration, and all of us love the best one is pain. So we have all of these receptors, and they're all distinct receptors. They're not one little machine. There are different receptors that each sense different types of pressure and so forth. So we're going to talk about this in detail later on. We can also use our skin to express ourselves, whether we're smiling, which I'm not very good at, or love or hate or so forth. It's hard to cover up those emotions many times because they show in our facial expressions and also in our color of our skin. We blush and pale even when we get very emotional about things. So it's a means of communication. And now the rest, I guess this is what we have left. We'll talk about what we call the derivatives of skin, the tissues in skin or other parts of this large organ that play a role in its function. And the first we'll talk about is hair. And the function of hair, protection, that's largely, when you try to describe the protection that hair offers us, you might first think about the scalp and prevents sunburn, maybe gives us some shade. I don't know if that's very valuable. But what most of us are thinking of is protection from inhaling particulates through the skin, through the hairs that are part of our respiratory pathways, and also in the outer ear. We have hairs that prevent such things as cockroaches climbing in your ears. So anyway, they do offer us protection from varying means. And as some of you know and can certainly recognize it from the room, by the silver fox, the hair definitely is part of our attraction for each other. I know that the guys here probably fear me being in the bar with them at the same time because I'm good looking. But anyway, we spend a lot of time on our appearance, and it does play a role in, you know, when you pass someone in the hall, you have to look back and see what you pass. So anyway, it plays a role in our attraction for others. The hair is composed of a shaft, which is a column of keratin. Now, I mentioned quickly last time, the keratin is a protein, but it comes in many, many forms. And in cell biology, they have a table, and they'll talk about all different forms, but most of which is how much cross-linking this protein does with other keratin molecules. And they have a group of keratins called hard keratins, and those hard keratins play a role in the hair follicle or the hair shaft and also the fingernails and so forth. So this is a product that also not only is laid down on your skin as a water barrier, but in the right type of organization, the protein can form a very solid structure as in a hair. The root of the hair is just a part of the hair shaft that's below the surface of the skin. So from the surface on down, they call that the root. And the follicle is a depression in the epidermis that gives rise to the hair. So the keratin is produced down here in the bulb, but the whole structure is called the follicle. There's a muscle, interestingly, attached to every hair follicle called the erector pili that holds the hair in a direction, either upright or when it's relaxed against the surface of the skin. So all of us have these erector pili muscles, and in us it's largely vestigial, but it does play a role, as we'll talk about, in more primitive they are in other organisms. It contracts in cold and emotional crisis. So you've got a cat or a dog in your home, when it's cold, their erector pili muscles contract and their fur becomes thicker, and so it's a thicker coat essentially and keeps them warmer. The same happens when they're frightened. So when the dog goes by and the cat gets upset, it'll raise its skin and look a lot bigger. This occurs in us too, but it's not too effective. In other words, you've seen goose flesh when you're cold. That's essentially the erector pili muscles. It's not really helping much. And when you're scared, you're heading out to your parking lot, it's dark at night, and you get frightened, you'll also have the erector pili muscle contract, and you can turn around and scare the guy behind you with how big you are now. But anyway, obviously it doesn't have much function in humans, but it used to be pretty important in more primitive organisms. Look at me now, you're scared. The color of this hair is, again, largely the result of melanin. So it primarily is due to how much and what type of melanin we have. For example, black versus blonde hair is essentially people with black hair have far more melanin in their hair than blonde people do. There's another element, another colored protein, however, called tricosiderin that's an iron-containing pigment that does give red color to some people's hair. And finally, those of us who are in the gray fox area, I hate this little phrase, I don't mind black pigmentation, but air bubbles kind of indicate some airhead kind of quality, which I'm definitely heading towards, but I don't want to admit it. Oh, I should mention that I've done some research. There's one of the color that's unique to South Florida, and that's blue, especially down in Miami, blue hair, and I haven't exactly figured out where it comes from, but I have noted it's kind of a Miami phenomenon. Okay, then fingernails. Also another derivative of skin that's largely due to keratin and protects the end of your, if you've ever lost a fingernail, you know that you're, without that fingernail there, you hurt your finger, you're always running your finger into something. It's amazing how much it does protect the area from pain, from being, getting in the wrong place. And of course, we use fingernails all the time for object manipulation. I always tell this story, so I apologize if some of you heard me tell it before, but a couple of years ago, I went to Publix, and there was one of these ladies working the cash register who had very long fingernails that came out from her hand, came around quite long. And I was fascinated, so when I walked up to the counter, rather than put my debit card through the machine, I handed it to her, because I put it flat on the thing, because I wanted to see what she'd do. And she kept pushing it around, couldn't figure out what to do. The guy behind me started reaching for it. I pushed it back. Because he had something to do with the day I didn't. So anyway, she kept pushing it around, and finally she got it right on the edge. She got a piece of paper and was able to slide it up on the paper. But the point is, it's hard to manipulate your environment without these little extensions that are valuable. But anyway, the value of fingernails. Fingernails have interesting parts. The body of the nail is the majority of what we call fingernails. I refer to it as the nail plate or body. The lanula is that clearer area right near the cuticle, or what we call a palmacium. But it's the area where they think growth is going on more rapidly, so it usually is clearer or lighter than the rest of the nail. The nail root, like the root of a hair, is that's below the surface of the skin. And hyponychium is attachment of skin to the nail, usually underneath the tip of the nail, as is represented. Those are just principal terms we use for the parts of a nail. A little bit about the glands that are found in skin, and we're going to talk about glands off and on through the whole year. But sebaceous glands are glands that are particularly associated with hair follicles that are represented right here, just more superficial than the erector pili muscle. And they can produce their Holocrine glands. Remember, those are the glands at the top. The apical end of the gland breaks off, and they secrete a very oily material called sebum that has lots of lipids and even antibiotics in it that are used to keep the hair pliable so it doesn't break as much. Sebaceous glands are represented right here. Unfortunately, there I am again. I turn that off all the time, and then I have to call a dumb guy for the phone. There we go. I should make you say hi to my wife. Sebaceous glands are glands that also produce oily material that secrete it right to the top. And when these get infected, that leads to a acne condition. So that's thought to be the principal cause of acne. And here's some acne, just so in case you don't remember what acne is. Tudiferous glands are sweat glands, and they're represented right here. There's actually two different forms of sweat glands, apocrine and eccrine. And I mentioned how important this release of water on the surface of our system is, and they really are very valuable in keeping us cool. Plus, this is ridiculously unimportant, but it's brought up in every class, a way of getting rid of urea and some other byproducts and metabolism, but that's so unimportant it's not worth mentioning. Again, there are a couple types of sweat glands. The merocrine glands are also called the eccrine glands, are most dense in the palms and the soles, palms of your hands and soles of your feet, but also found in your forehead, back, and neck. And they are, again, very important for, this evaporative cooling, for thermal regulation. And not only do we release water, but also electrolytes. Most of the osmolarity is about 150 millios, so they're about half of the plasma osmolarity. But they also have some metabolic byproducts and even some drugs in them. That's been used in some cases as a way of proving an individual used a certain drug, but it's, again, not very valuable. By far the most important is the thermal regulation aspect. The other type of gland is found in very specific places, axillary and pubic, and that means the armpit and the special places. But these are associated with hair follicles, and they not only produce this hypotonic solution, but it also has some organic constituents that make it odoriferous, is a kind way of saying. And so, again, maybe some of this is vestigial in us, but this is why the dogs smell each other and the cats smell each other, because it has some attractants in it. We keep using these all these material we put in our armpits, whatever you want to call it, and to get rid of this odor, because we don't seem to get into smelling each other's armpits, but the cats and dogs really enjoy that. And anyway, it's supposed to attract the opposite sex pheromones. Another interesting story about African glands is they don't function much until puberty. So the other glands function right from birth, and so they have the cooling sweat activity very young. But as children grow up, there's very little production of this organic material until they reach teenagers. And then if you've had some kids in your home, you know when this happens, because all of a sudden they stink and you tell them to go take a shower. So this is the time when your children are sent to the shower because they start smelling around a lot. So anyway, African gland begins really functioning at puberty. And they secrete during sexual excitement and stress, so that also makes sense with the idea that they contain pheromones and attract others, the opposite sex. And finally, a little bit on mammary glands. We'll get back to these when we're in the reproductive area of the course, which is until second semester. But this is a class of seediferous gland that produces milk. It's very complex as far as its controlled by hormones, and we'll talk about that a lot later. But it consists of these acini that are very complex and keep emptying into ducts that gather together and so forth. So it's a very large, complex, compound acinar process. And finally, a very restricted group of glands called the ceraminous glands they're restricted to the external auditory meatus, or the receptor for these cotton swabs that some of you use. And they secrete this waxy material called ceramin. And it functions as a water block, so you don't get swimmer's ear, I guess, but it doesn't seem to work too well, and an insect repellent. So it's supposed to keep insects and water out of your auditory canal. And some people have an excessive amount of ceramin production and end up with blocked ears quite often. And I think that, I want to talk just a couple comments about pathology related to skin, and put a friend up here. And just for sake, I'm not going to test you on this, but I think you should all know as a member of society how we classify burns, and if you get into this area as a clinician, you'll get far more information. But first-degree burns are used to describe a burn in which there's just a little bit epidermal damage, and so you have the area, you have pain and edema, swelling, and redness in the area. Once you start getting blisters, you damage the dermis. So the next level of damage is to extend the damage to the tissue down into the dermal area, and you start getting pockets of fluid or blisters. And then finally, if you lose or destroy the entire tegument, and sometimes even the muscle below it, we call it a third-degree burn, and you'll have scarring and ulcers form and so forth. And we'll talk, in various parts of the class on things like what causes these vasodilatation to occur and the redness, what causes capillaries to filter and leads to swelling. These are all parts of our system functioning, especially in cardiovascular system. When you start dehydrating, which is the major problem with secondary burns, you get dizzy because of low blood pressure, and you pass out, and you can lose blood flow to specific areas. These are all things that occur with dehydration. So although I'm not going to have you memorize, all this is normal physiology gone awry, and we'll talk about it off and on in the class. So that's where I was going today. We'll go from here on.